Okay, so notes 2, margin of errors. Says important notes on confidence intervals. So this is kind of like our little recap from our last notes. Says margin of error does not mean that a mistake was made in data collection. It accounts for natural variability. Okay, that exists when taking a sample from a population. So natural variability means, let's say we are collecting that sample and unexpectedly we have some bias that we didn't mean to put in. Okay, maybe that was out of our control. Okay, so it's natural variability is something where the standard deviation is going to vary by sample based on things that we can't always control. So for example, let's say I was taking a sample from our population of our class, okay? And I was going to see how well you guys did on a test. Well, what would be some factors that are going to be out of my control that determine whether or not you do good on a test? Study, right? That's out of my control. I can tell you to study all I want, and it is completely up to you if you're going to go home and study, okay? I also can't go to your house and stand over your shoulder and make sure you're studying for statistics, okay? Another person said sleep. I can't control if you're going to get a good night's sleep, okay? I can't control if you work till 2 in the morning, you stay up till 4 in the morning playing video games, or you just decide that sleep is not for you, okay? All of that is going to control how you take a test, which is going to change my sample when I am collecting those data points. Large samples are always better. However, if the sample size is large relative to the population, the proper inference we should use will be different than those taught in AP statistics. So what that means is, for now, our idea of larger the sample, the better the data, is what we're going to stick to for this course. If you decide to take another SATS course in college is when you would learn other inference methods. You must always name your inference procedure either by name. So the one that we talked about yesterday was the one proportion Z interval, and this is like the short name for it. Yesterday it was like we called it the one sample Z interval for proportion. This is the same thing. It's just another way to say it, a little less words. Okay, or by using the generic formula. So you must always name the inference or name the formula. Okay, yesterday on that FRQ that we did together on the notes, I told you to do both. Okay, it's better to have more information than it is to have not enough information. But let's say you're taking the test, you completely forget the name, you have the formula chart to at least write the formula down. Okay, next part I'm going to show you how to do a one proportion Z interval on Desmos. So I'm going to go ahead and cross that out to write my steps, and since I am on technology, I'm going to erase this. Okay, so you could cross it out or use a sticky note if you have one. Okay, so the first step on Desmos is to add an inference, just like we did before. The only difference is we are no longer clicking on probability distribution to go to the standard normal distribution. Instead, we're going to look for the z-test for proportions. Okay. From there, okay, is when we are going to put in our number of successes. Okay, so X stands for the number of successes. There's another C. Okay, and then we have N, which is the sample size. Okay. And then we have the C percent, which is our confidence level that we need to make sure that it is written as a decimal. Okay. Once we have all that information in, it's going to give us the interval. Okay. Once we're given the interval, what's nice is, so let me see, it's going to give the interval. There's also going to be these 3 dots that are right next to the interval. And if you click on that, it's going to give you your p hat value. Okay. So remember, when we calculate p hat, that is the estimated proportion, like our proportion from a one sample or one simulation. So the p hat value is going to come from your number of successes divided by the sample size, so x over n. But we don't need to calculate that because Desmos is going to do it for us. Okay. So we are going to look at the next example, and we're going to use Desmos to solve. So I'll give you guys a minute to finish writing that down. Okay. So in the example, it states a poll was conducted at a large university to see if students preferred virtual classes versus in-person classes. The poll found that 175 of the 340 randomly selected university students said they preferred virtual classes. Part A says, what is the 99% confidence interval for the population proportion, assuming all conditions are met? So using Desmos, I'm going to first identify what is my X, my number of successes, what is in my sample size, and then what is my C percent. So I have these numbers here, 175, 340, and 99%. What is 175 going to represent? X or N? X. And then 340? N. So on Desmos, I'm going to follow my steps. I'm going to go to add an inference. And then where it says inference for categorical data, right below that it says z-test for proportions. That's what I'm going to click. And then it's going to give me successes and sample size. Remember, successes is X, so 175. And sample size is N, so 340. And once you hit create test, 2 things are going to pop up: confidence interval and significance test. Which one are we learning about right now? Confidence interval. So I'm going to do that drop down, and then notice it has a place for me to put the confidence level. And what am I going to put here? 0.99. So from here, it gives me my interval. So I can go back and I can write, well, my interval for the 99% confidence is 0.445, comma 0.585. So what that means is within this interval is going to give us the possible p-values for the scenario. Okay, so the possible amount of students, or the proportion of students who prefer virtual classes, if we were to repeat this again. So between about 45% and 59%. Okay, the next part asks for the point estimate. So remember, you click those 3 dots right there, and the point estimate is our p hat value. So we're going to write that p hat is equal to 0.5147, and I'm just going to write the first 4 decimals. Okay. Then the next thing it's going to have us find is the margin of error. So don't confuse this with standard error, okay? Because I don't want you to look at Desmos and say, oh, well, awesome, it gave it to me. It's 0.0271. That is not the same as margin of error. Margin of error is us taking the upper bound, which I'm going to abbreviate as UB, and subtracting p hat, okay? And the upper bound just means the greater value in our interval. Or if you look at the 3 dots, the drop down, it says upper bound there. Okay, so I'm going to take my upper bound, which is 0.585, and subtract p hat, which is 0.5147. Okay, and because I don't want to make an algebra mistake, I'm going to go over to Desmos and subtract that. And I get that the margin of error, which remember abbreviation is ME, is equal to 0.0703. Okay, any questions so far?
Can you go back like on the Desmos?
Go back on the Desmos?
Yeah, I missed like a whole bunch of it.
Yes, I will go back. I just exited out, that's why. It's okay, okay. Yes, going back to Desmos. So going through all the steps again?
Yeah.
Okay, so I'm going to hit the plus sign, add an inference. Okay. From the inference, you're going to see inference for categorical data. We're clicking on z-test for proportions. Okay. The number of successes is our x value, and we said x is the 175. And our sample size is our n value, which is 340. And then we hit create test. I don't think you're on the right one. That first one. Yeah, so 175 and then 340. Okay. Once you get to that point, you're going to click on confidence interval drop down, and that is going to leave you to put in your confidence level, which in our problem was 99%. So we're going to put 0.99. Let me see if I can make it. Okay, and that was because it said 99% confidence interval. So once you put 0.99, the numbers that are popping up is your interval. So that 0.445, comma 0.585. And then in order to find p hat, which is our point estimate, if you click on those 3 dots that are on the interval, it's going to open up a table, and there you will find your point estimate, which is p hat. So point estimate, and then that number is p hat. Okay. Any other questions? Okay, so once we found the interval in p hat, that is when we found margin of error, which is our upper bound. And upper bound just means the greater number in our interval, okay, minus p hat. We take those two numbers and subtract them, and we get 0.0703. Okay. The next two parts is telling us to interpret the interval in context and then interpret the confidence level in context. So what that means is using those sentence stems that you guys highlighted yesterday in the notes. Remember the ones I told you to box, star, because you're going to come back to them? You're going to use those sentence stems to fill in the interpretations. So for example, part B says interpret this interval in context. We always start the sentence stem as we are 99% confident that the true proportion, now we're bringing in our context, so of university students who prefer virtual classes is between, and then we write down the numbers that we got in our interval. So is between 0.445 and 0.585. Okay, so that's the first sentence stem for interpreting the interval in context. And everything that I'm going to highlight is part of the sentence stem. So we're always going to put, we are blank confident that the true proportion of, and the rest is context, university students who prefer virtual classes is between blank and blank, your interval. So everything else is context. Okay, or things that are going to be given to you in the problem. Okay, remember that a confidence interval is us running the sample one time. Okay. A confidence level is if we were to run multiple samples of the same sample size repeatedly, like hundreds of thousands of times, then we would be